So, hope you're doing good and welcome back to my channel. Today we are at day 8 of the May daily Leetcode challenge and we have easy level question in front of us. Let's see what the question is. It's question 1572 matrix diagonal sum. Okay. So we are given a square matrix, okay, mat, and we have to return sum of its diagonals, okay. So only include the sum of all the elements of the primary diagonal and all the elements of the secondary diagonal that are not part of the primary diagonal. So let us quickly see the example here. See, whenever the uh, for example, the side of a square, right? If the side is odd, if the length of the side is odd, okay, it's a square of side odd, okay, odd number. See, then in that case, the primary diagonal and the second, see, this is called the primary diagonal. See the image here. This is called the primary diagonal. This is called the secondary diagonal, right? So the primary and second diagonals will have a same element if the matrix length is odd, okay. If it is just length is even, see, it will look like this, okay. So until you see the primary diagonal and the second diagonal will not cross each other, that means they will not have any elements in common. That is the basic idea of this question, and we have to return the sum of them. Okay, and in case of odd length, okay, that means in case when the secondary and the primary diagonal have a common element, we should count the common element only once. That is the basic idea of this question. Okay, so that's all what they are trying to say, that we should not count any element twice. Okay, if it is present in both the diagonals, we should count it only once. So then we have to return the sum. Okay, so you can clearly see the diagonal sum is like this: 159 plus 3 plus 7. Okay, and we have to return the sum. That was all, and you can clearly see its length is 100 and this is square. So, see, brute force approach will be going through the each of the elements and checking if it lies in the primary or the secondary diagonal and adding it. Okay, that will take O of n square in time complexity. But I am going to say a solution which is O of n, and let's see how the solution works. N is the length of the side. Okay, answer, this is going to be my final answer. I'm initializing it with 0. I am going to start my I from 0 to n. Okay, it will rotate from 0 to n. What we're doing is, see, this is a property of a square. Okay, see, the primary diagonal elements, if you see very carefully, see, first element is 0 comma 0, 0 comma 1, 0 comma 2. This is 1 comma 0, 1 comma 1, like this. So if you could see carefully, all the limits in the primary diagonal have a index such that both, see, for example, there is a x comma y, okay, index. So if you see the index, x will be always equal to y. For example, 0 comma 0, 1 comma 1, 2 comma 2, 3 comma 3, like that, n comma n. So all this is how we identify if element lies in the primary diagonal or not. So suppose I have a number I. So if I have to find, suppose in the I row I have to find which element lies in the primary diagonal, I will say I comma I is the element in the primary diagonal. So that is how I'm getting the diagonal. So once I see, I will be, suppose I is the number of row. Okay, in 0th row I have to find the element which lies in the primary diagonal. So this element is the 1. Okay, math of I comma I. Okay. Now I will find the element in the secondary diagonal. How to do that? See its property. For the 0th row, what we are doing is we are taking the last element. For the first row, we are taking the second last element. For the second row, we are taking the second last element, and so on. So just try to link the approach. For the 0th row, last element. For the first row, second last element. Okay. So what we are doing is, see, this is what we are doing. For the first row, okay, so sorry, for the 0th row, last element. Okay, n minus 1 minus 0. For the first row, second last element, that is n minus 2, because I will become 1, so it becomes n minus 2. Then that's how it works. Okay. So if we say j is equal to n minus 1 minus I, then for the ith row, we are going to take this element. So I comma j will form the element of the secondary diagonal. Okay. But as I said, when the length is an odd one, then the primary and second diagonal will always have a one element in common. So what we can do is we can check if the I is not equal to j. Only then I will add it to my this thing. Okay. This condition is required in case when the length is odd. Okay. Otherwise, this condition is not required. You can do another optimization here. You can just check at the starting itself if the length is odd. We will require this. If the length is not odd, then we do not require this update. Okay. You can add another if condition there. Okay. So yeah. So this thing is for the first primary diagonal, and this is involved the secondary diagonal. And we are going to add a second diagonal element only if not like the primary diagonal. For that, we are doing this condition. And finally, we are getting the answer. Okay. So yeah, I will just. Yeah. So coming to the space and time complexity of it, see, we are going to running a for loop for 0 to n. Okay. So the space complexity will be O of n, and the time complexity will be See, space complexity, sorry, it will be over 1 and time will be over n. And if you see the solution here, yeah, it's clearing all the test cases. It's nearly 80% faster than all the Python solutions. We are not using any new idea or anything. That's why space complexity is over 1. And we are using only single for loop from C. For both primary and secondary calculations, we are using a single for loop. So the time calculation will be over 1. So yeah, friends, that was all for today. If you have any questions, please do comment below. And if you have even better optimal solution, then also please do comment below. We can discuss further. Thanks a lot for today.